Okay, let's go through the practice test. For each of these, there are little things I'd like you to watch for that, I kind of mess people up when they do these answers. So let's start off here. Okay, the first kind of questions we're asking you to say, is this exothermic or endothermic, or, you can't really tell either one. So calcium chloride, when dissolved in water, warms up. Okay, calcium chloride, when dissolved in water, warms up. That is exothermic. Okay, the idea there is we're talking about the chemical process. So calcium chloride, when it dissolves, okay, it gives off heat, and so we can sense that. This is like the baggie we passed around in class. What is the baggie? And we can feel the heat coming off of that. So the reaction's giving off heat. We can feel that. Okay, energy is absorbed in a reaction process. That's the definition of endothermic. Okay, energy on the left side, that means energy is going into the reaction. That's endothermic. Okay, downhill graph. Okay, if you're going from high energy to low energy, it must be because you are losing energy. You're giving off energy. So that is exothermic. Downhill is exothermic. The reaction mixture has a temperature of 200. That is the one that's either, because, is it going up? Is it going down? Is it absorbing heat? Is it, we have no idea. We're just saying it happens to be at 200. So we're interested in what's the flow of heat. What's the flow of heat? And just at 200, you can't tell. Okay, Q is negative 250 joules. Okay, a negative number comes when you are starting with a low number and ending with a, beginning with I, ending with low, beginning high, because it's final minus initial. Be a small number minus a larger number, that's when you're going to get a negative number. So when we get a negative Q, we know that that is exothermic. Okay, when we're going to go uphill, we're going to be a big number minus a small number. So anyway, Q is always final minus initial, so negative means exothermic. Okay, look at the next questions. Which of the following is true about the freezing of water? That shouldn't be if water, that should be of water. Okay, the freezing of water. And we have liquid going to a solid. Okay, is that true? Liquid going to solid, is that freezing? Yes. Okay, liquid water freezes to solid. And would heat be on the right side? Yeah, heat always goes on the more solid side. So we're saying that, when freezing happens, that's exothermic. So yes, this is true. Okay, is Q greater than 0? Okay, exothermic means it's going downhill energy-wise. That's going to be a small number minus a big number. Okay, that's going to be a negative value, so that is not true. And molecular attractions are weakened. Well, you could think of a solid. That's pretty strong attractions, starting from a liquid, which is less strong. So okay, no, they're being strengthened. They're not being weakened. So that's not good. So the only one is one only. Answer A. Remember, this kind of question is really 3 separate questions. Think about them individually, and then go find the answer. The units for specific heat. Okay, specific heat. You have to know we're talking about CP. And you can think about this. If you don't have it memorized, you can think about it. And that is, we know that Q is equal to M delta T CP. So if we were trying to get CP by itself, it would be Q over M and delta T. Okay, those would cancel. And what do we have? We have Q is in joules divided by mass, which is grams, and change in temperature, which would be degrees Celsius. So joules per gram degree, that's going to be answer D. Okay, or you can just memorize that. Specific heat, joules per gram degree. Okay, which of the following is true for an endothermic process? Endothermic process. So what do we know? Endothermic is going to go uphill energy-wise. You got to put energy in. Okay, so heat is a product. No, heat's one of the reactants. Okay, heat as a product is exothermic. Q is less than 0. Q is negative. Okay, that is not true. Q is positive because it's a big number minus a small number. The reaction mixture may increase in temperature. Okay, let's think about that one. And the reaction releases heat. No, the reaction does not release heat because it absorbs heat. Okay, so the answer must be C. Now, let's think about this. We know it's C because we can eliminate A, B, and D. The reaction mixture may increase in temperature. If we have a situation like we were talking back here, where calcium chloride, dissolves in water and warms up, that was exothermic. Okay, but the idea here is you can't always tell exothermic and endothermic by whether it heats up or, the temperature increases or decreases. Because you could have the situation of, let's say, a container of water, and you put that into an oven, okay, and if you put that into an oven that's really hot, then energy is going to go into the water, okay, and the temperature of the water is going to go up. But as far as the water is concerned, that is endothermic. Okay, so which of the following is true? It may increase in temperature, okay, depending on the situation. So anyway, this question you would do by eliminating A, B, and D. Okay, number 10, a substance with a high specific heat. Okay, so high specific heat, it takes a lot of joules to change a gram of that stuff 1 degree. Okay, high specific heat means it has a great resistance to change in temperature. Those are the things you should think about. So is it a conductor? No. Conductors are things that are easy to change their temperature. Is it exothermic? Okay, you can't say it's exothermic. That's the change in the heat. So just because it has a high specific heat or a low specific heat, it could be exothermic or endothermic. So you can't say that. Metals are typical examples. No, metals are examples of conductors. Metals usually have very low specific heats, small specific heats. They're easy to heat up and cool down. Requires more energy to raise the temperature than a substance with a lower specific heat. That is the answer. Okay, it's something that resists change in temperature. Specific heat resists change in temperature. Number 11, which of the following is an example of an endothermic process? Okay, who's endothermic? Combustion, no. Burning, combustion, burning, releasing heat. So no, that is not the answer. That's not endothermic. Dissolving of calcium chloride, which feels warmer. No, we talked about that earlier. Okay, that as that dissolves, that is going to give off heat. That's exothermic. The freezing of water. Okay, think about that. Water freezing, so that's for water liquid changing into water that's a solid. Okay, and we put heat on the more solid side. So that's actually an exothermic reaction, and it makes sense. You got to put water into a freezer so it pulls out the heat, so it loses heat. So no, that's exothermic as well. So the vaporization of ethanol when heated. Okay, so ethanol, so we're talking about something that is a liquid becoming something that is a gas. We're going to put heat on the more solid side, which in this case is a liquid. So this is the answer D. Vaporization of any liquid actually would work. Number 12, 30 grams of liquid ethanol and water are heated at the respective boiling points. Which sample will take longer to vaporize completely? The delta H of vaporization. Okay, so we have two different heats of vaporization for two different substances. Now we've got to think of this, and this is not a calculation. This is a think about it problem, and we're saying that this one here resists change in phase. Okay, the larger delta H is resisting change in phase. So what are we talking about? 30-gram samples, which will take longer to vaporize completely. Okay, this one's going to take longer to vaporize completely because it resists vaporization because it's a larger delta H of vaporization. So the answer is water, answer B. 13, which of the following is the correct equation for the condensation of water? Condensation. You can see what's happening is these are the same equation, liquid to gas, and these are the same gas to liquid. Okay, so they're backwards and forwards and heat's on different sides, so we have to figure out which one's correct. So we say condensation. Condensation, we should know, is a gas changing into a liquid. Okay, so we can eliminate those first two because those are not, those are vaporization. Now, heat goes on the side that is more solid, so I'd say the liquid is the more solid side. Okay, so we're looking for an answer, gas going to liquid with heat on the right, answer D. Okay, 14. Which of the following takes place initially when heat is added to a block of ice at 0 degrees? Now, block of ice is important, but at 0 degrees is also important. So we're thinking kind of back to our heating curve. And we say if I had ice that was down here at negative 20 degrees, then I would have to warm it up first. But if I have ice that's right here at 0 degrees, it's just going to melt. Okay, so the ice melts. The temperature increases? No. If it's at 0, it's going to stay at 0 until it's melted. Molecular attraction strengthen? No. If we're going from a solid to a liquid, no, it is not going to strengthen. So the answer is 2 only, ice melts. It's just going to melt because it's at 0. Okay, blocks A, B are made from different metals and have the same mass. When they're heated with 500 joules of energy, block A increases 15 while block B increases 90, which has a larger specific heat. Okay, so what we're saying is which one is resisting change in temperature more? Which is resisting change in temperature more? So everything's the same. Block A goes up 15 degrees, block B goes up 90. Okay, who's resisting change in temperature? Block A. Block A is resisting change in temperature, so that has a larger specific heat. So look and see, what are they asking? Are they asking for large specific heat, small specific heat, or whatever? So it's block A. When a 20-gram sample is heated with 140 joules of energy, the temperature increases from 20 to 50.8. Which of the following could be the metal? Okay, well, if we just want to identify a metal, we say, well, here's 4 different C sub P's. So what the real question is, what is the CP of this unknown metal? And then we can match it up and see which answer it is. So this is really a calculation problem, and we're going to use Q equals M delta T CP. So we need to find Q, we need to find M, we need to find delta T, and then we're going to be able to calculate CP when we do all that. So let's say, so Q is 140 joules. The mass is 20 grams. The delta T, okay, is 50.8 minus 20, so 30.8 degrees. Now if I want to get CP, then CP is going to be Q divided by M and delta T, a little math here. So now we're going to put those in. So Q, 140, I'll put it over here, 140 joules divided by 20 grams and divided by 30.8 degrees. Okay, and that's going to give us our CP. So let me get my calculator. Okay, when I do that, I get 0.227 joules per gram degree, 0.227, so that must have been 10. Okay, so I'm actually solving this calculation. I'm going to solve it for CP, and then when I do, then I get one of these answers, and I get the answer for 10. Okay, now the FRQs. When a piece of glass is heated with 360 joules of energy, the temperature of the glass increase. We are heating up some glass, and we're given that CP, so we know the equation we're using is Q equals M delta T CP. Okay, so that's the clue of what equation. So we're looking for those things, okay, and we're saying what is the mass? So we're looking for mass. So Q is equal to the heat, 360 joules. We know the mass is what we're looking for. Okay, delta T, okay, it goes from 33.5 to 46.5, so that's going to be, it looks like 13 degrees. And the CP is given, and that is 0.84 joules per gram degree. So let's plug and chug here. So the 360 joules is equal to M times 13 degrees times 0.84 joules per gram degree. Okay, and I'm going to be left with grams because joules cancel out, degrees cancel out. Okay, so now I'm going to solve for M. So M is 360 divided by 13 divided by 0.84. It's really messy. Okay, and I'm going to calculate. And I get a value of 18.6335. So I'm going to say 18.6 grams. So that's what I think I have here. So a piece of glass, okay, just put it into my Q equals MC delta T, find my variables. This is going to be a 4-point problem because you're going to have the variables, the equation, which you should know that is. Okay, substitute in, get the answer. Okay, what's the final temperature when a 32-gram piece of diamond is heated with energy CP is given? Okay, the fact that we're heating up something, then I know this is Q equals M delta T CP. Okay, what's the final temperature? Final temperature. So we're trying to find the delta T, and notice that we are starting at 333.5, so I'm going to find the delta T and add it to 33.5, so keep that in mind. So we're looking for our variable. So Q is 360 joules again. Okay, the mass is 32 grams. Our C sub P is 0.509 joules per gram degree. Okay, so we're going to solve for delta T. So I'm going to substitute in, so 360 joules is equal to 32 grams times delta T times 0.509 joules per gram degree. And everything's going to cancel out except for degrees this time. Now, let's see, so I'm going to want delta T. So delta T is equal to 360 divided by 32 divided by 0.509. And let me get an answer. So my answer I get is 21.2 degrees, but that's not my answer because that is the delta T. So if we started with 33.5, so I'm going to add that in, then I'm going to end up with my final answer being 54.76. Okay, 66 degrees, so I'd call that probably 54.8 degrees Celsius. So that would be my final answer. Okay, so I'm going to find my delta T and then add it to 33.5 to get my final answer. Okay, 19. What is the value of Q when 55 grams of ice is melted? Okay, well now if we're talking about melting ice, it was not the same equation. Now it's Q is equal to the mass times the delta H. And since it's melting, we're talking about delta H of fusion, which is given to us right there, 333 joules per gram. So all I need to do, what's the value of Q? So Q is what I'm looking for. And mass is 55 grams. And delta H of fusion is 333 joules per gram. This is really messy. So my Q is equal to 55 grams times 333 joules per gram. And my calculator, say 55 times 333, I get 18,315 joules. Now, what's the value when ice is melted? When ice is melted, okay, if I'm going to go from solid to liquid, it has to absorb energy. So this would be a positive value, 18.315 joules positive. Okay, what's the value of delta H of vaporization of methanol if that many joules is released when 24.5 grams of methanol condenses? Okay, so we're talking the same thing. We're saying Q is equal to mass times the delta H, in this case the delta H of vaporization. So what's my Q? Q is 27,050 joules, and my mass equals 24.5 grams. Okay, so I want to know what is my heat of vaporization. So I'm just going to throw these numbers in. So 27,050 joules equals 24.5 grams times delta H. I wanted to solve for delta H, so I'm going to divide both sides by 24.5. And I get 27 divided by 24, so 27,050 divided by 24.5. And I get a value of 1,1104 joules per gram. Okay, and I'm trying to condense it. Oh, it's condensing, so it's going to give off energy, so I could call that negative. Okay, because condensation is exothermic. But the number is 1104 joules per gram. So the delta H of vaporization, okay, actually it's a little odd. The energy is going to be negative, but I think I would call my answer positive because the value of heat of vaporization is, for vaporization, so it would be a positive 1104. We'd be looking at the number. We're not worried about the sign. Okay, explain why it feels cold when ammonium chloride is dissolved in water. Okay, why does that feel cold? Okay, and the idea is as ammonia, NH4Cl solid, changes into NH4Cl aqueous, okay, the chemicals absorb heat, and if they absorb heat, okay, it's going to removing heat from the surroundings. Okay, which is going to be the water and your hand. Okay, so it feels cold. So as ammonium chloride turns into ammonium chloride aqueous, solid turns into aqueous, the chemicals absorb heat, okay, and they remove that heat from the surroundings, and so if they're removing the heat, it's lowering the kinetic energy, and it feels colder. Okay, so here's our answers. The process is endothermic, so when the system absorbs heat, the energy or the temperature from the surroundings and your fingers decreases. Okay, that works. So I think we got the right answers. Yeah, positive 11, 18,315, that's good. 55 point, they got 54.8. They got 55.6. I got 54.8. Okay, we better check that math. And 33 grams. Ooh, 18.6 grams. Okay, well, I'm going to stop the tape here and check my answers on 17 and 18. Okay, I'm not sure what I pushed the right button there. On 17, then I went back and checked my math, and so my setup was perfect, but my math was all wrong. And when I redid the math, then I got an answer here of 33.0 grams. Okay, 32.97 something. Okay, so the answer is really 33 grams for 17. Okay, I just went back and checked my math again. Okay, again, my setup here is fine. Okay, but when I got done, I did not get this. Okay, I got 22 point, oh boy, let me calculate it again. 360 divided by 32 equals, divided by 0.509. I get 22.1. Okay, so when I add that to 33.5, I get an answer of 55.6 degrees, which is what matches the answer down below. So be careful with your math. So my setup is good, my math is terrible. Okay, so luckily I got these other two correct, so I don't feel too bad. But okay, be careful. I would have lost points on this test. So checking our answers. The answers are correct down here. Okay, that is the practice test.